Hello, and welcome to our first episode of the Atmosphere series. In this episode, we will discuss the importance of the atmosphere. This is a very basic overview that is aimed at grade 10 learners. So what exactly is the atmosphere? The atmosphere is the layer of gases that surround the Earth. It protects all life and allows us to breathe. But why is the atmosphere so important? There are a number of reasons for this, but we'll discuss the most important reasons in this episode. Firstly, the atmosphere provides us with oxygen for respiration. The second reason is that the atmosphere contains carbon dioxide that plants use in their process of photosynthesis. Thirdly, the atmosphere contains water vapor. This is a source of water that is also part of the water cycle. Another reason is to do with wind movement. Wind moves from an area of warmth to an area of cold and vice versa, which creates an atmospheric pressure equilibrium. Without this movement, the polar areas would continue to become colder and the equatorial regions would become hotter and hotter. In the event of this, life on Earth would cease to exist. The final, and perhaps one of the most vital uses of the atmosphere, is that it acts as a shield around the Earth. It protects us from solar radiation by absorbing UV rays and burns up meteorites that enter the Earth's atmosphere. Now that we've had a look at some of the reasons as to why the atmosphere is so important, let's move on to discuss what makes up the atmosphere. What is it composed of? The first thing that is present in the atmosphere are gases. The atmosphere is made up of two types of gases. The first type, permanent gases. These gases do not change in proportion. Instead, their percentage remains somewhat constant. The second type are variable gases. The percentage of these gases change from time to time in the atmosphere. Here on screen, you can see a table that provides more details about the different permanent and variable gases in the atmosphere. Permanent gases such as nitrogen, oxygen, and argon have many uses. These uses range from being used in plant growth, for respiration, and can be used in electrical appliances. The variable gases, such as carbon dioxide and water vapor, are used in photosynthesis and act as a source of water. Next, we can find liquids in the atmosphere. These are found in the form of condensation in the rain and the clouds. Dust, smoke, ash, salt crystals all form something that are called condensation nuclei. These condensation nuclei provide a surface on which water vapor can condense in the atmosphere. Now, what does the atmosphere look like? What is its structure? First, we need to understand what the structure refers to. This refers to the different layers in the atmosphere. But how are these layers determined? They are determined by how much the temperature changes with height, so how much warmer or colder it becomes the further away from the Earth's surface you go. Here, you can see a diagram of the structure of the atmosphere. As you can see, we have 4 different layers: the troposphere, the stratosphere, the mesosphere, and the thermosphere. The stratosphere also contains the ozone layer, which we'll talk about in more detail later. And each layer has a pores layer, like the mesopause that you can see in this diagram, which acts like a transition layer in the uppermost part of that layer. Let's discuss the troposphere. The troposphere is the layer in which all life occurs, where we live and the closest to the surface. It is here where we see the tropopause experience temperatures from -60 degrees Celsius, but on average, near the surface, the troposphere has a temperature of 15 degrees Celsius. The troposphere exists 17 kilometers above the surface at the equator and 8 kilometers above the polar regions. Here, you can see where the troposphere is located above the Earth's surface and where the tropopause is located. The next layer is the stratosphere. The stratosphere is the layer located above the troposphere. It stretches for approximately 50 kilometers above the Earth's surface and has a temperature range of negative 60 degrees Celsius at the tropopause to 0 degrees Celsius at 50 kilometers. The stratopause has a constant temperature. Interestingly, the stratosphere houses the ozone layer, which causes the increase in temperature as it filters out UV radiation. Here, you can start to see the progression of the layers and the location of the ozone layer and stratopause. The third layer is the mesosphere. The mesosphere extends 50 to 80 kilometers above the Earth's surface. The temperature decreases from 0 degrees to negative 80 degrees Celsius. The mesopause is quite thick at 10 kilometers and has a constant temperature of negative 80 degrees Celsius. Now we can see how we're building up onto different layers of the atmosphere that extend into space. This diagram shows us the mesopause and the mesosphere. Finally, let's talk about the last layer, the thermosphere. This is the final layer of the atmosphere that extends from 80 kilometers above the Earth's surface to the limit of the atmosphere. It's incredibly high in temperature, and these are caused by nitrogen and oxygen absorbing the radiation and creating heat from the sun. Interestingly, the thermosphere contains the ionosphere and the exosphere. The ionosphere is the lower limit of the thermosphere that contains the particles that absorb radiation and create electrically charged ions, hence the name. Then, the exosphere is the very outer limit of the thermosphere that extends for 550 kilometers into space. This diagram shows the position of the thermosphere, the ionosphere, and the exosphere. To recap, the troposphere is warm, the stratosphere goes from cold to warm, the mesosphere goes from warm to cold, and the thermosphere goes from cold to extremely hot. So there you have it, a very basic overview of the importance of the atmosphere and what the layers are like. In the next episode, we'll dive deeper into the ozone layer.